My name is Kirt Onthank. I'm a professor of biology at Walla Walla University. Right now we're in the cold seawater lab where we keep all of our cold water animals, including our octopuses. So just recently, my graduate student Sophie Sonner and I published a paper in the Proceedings of the National Academy of Sciences. Where we're looking at how much energy does it take for octopuses to change color. Now, octopuses are probably the best animals on the planet at changing color. And it turns out from our findings that it takes them a ton of energy to do that. It actually turns out it takes them as much energy to fully activate their chromatophore system, the system that causes them to change color, as every other system in their body when they're at rest. And so it's taking equivalent of the rest of their body to maintain color change when they're resting. So that's really unusual for an animal. Most animals' organ systems at rest do not take up that much energy. In humans, our brains take up a ton of energy, but they're not taking up nearly the proportion of energy that color change does in octopuses, which is pretty incredible. And this also tells us a lot about why octopuses do some of the things that they do. Because if their color change, all their camouflage is taking so much energy, they're doing things probably to reduce the amount of energy that they have to spend on that. So most octopuses spend most of their time hidden away in dens where they can't be seen, so they don't need to use their color change there. So saving energy. Also, most octopus species are nocturnal, and we think that also might be a way for them to save energy on color change, because you don't need to change color to hide at night when nothing can see you anyways. So this was my graduate student Sophie Sonner's thesis research. And so this is something I've been thinking about doing for quite a while. And I have a list of research topics that oftentimes when a graduate student comes in, they don't know exactly what they want to do. We'll sit down, we'll go through these research topics that I want to tackle, and this was one of them. So her and I then, after we decided on that project, started brainstorming all the different ways that we could come about it and came up with this way of looking at where we take a small piece of octopus skin, put it in a chamber in which we can measure the oxygen consumption of that piece of skin. And from there, we can actually turn on and turn off the color changing organs just by shining light on it, which is pretty incredible. And so we could turn on and turn off the color changing apparatus at will and measure how much oxygen is that color change apparatus taking when it's turned on. All told, from like conception all the way through was probably about a year and a couple months. Like the entire length of the process for the research was probably about a year and 3 months. It started, I believe, in the summer of 2019, and it concluded at the height of the pandemic in the summer of 2020. And so we were all quarantined and finishing this up as we were going through there. Yeah, so it was about that long. And then the analysis took, honestly, like another year or two to do. So it was not a short project. At any level, at any type of institution, I don't know that I know of another master's student's thesis research that has been published in a journal, the tier of Proceedings of the National Academy of Science or higher. Like usually that's a PhD student's work or a professor's work that does that. So this research was done at Rosario Beach Marine Lab. And for an institution like Walla Walla to have a campus like Rosario Beach Marine Lab is absolutely unheard of. It is a phenomenal campus that allows really intense and really important research to happen right on the beach. And this is great because undergraduates, graduate students can go there for the summer and engage in work like this. So one of the unique things about Walla Walla University is that our undergraduates, not just our graduate students, but our undergraduates get involved in original research. Many of our undergraduates are publishing original research in peer-reviewed journals, and that's something that's not so common at institutions like ours, or really any institution. And also many of them carry it on into graduate work in which they get to carry out really high-powered research here that also ends up in peer-reviewed journals. Some follow-up questions I'm looking at tackling next are looking at different octopus species to see, does their color change system use different amounts of energy? We actually have a deep-sea octopus that lives very close to Rosario that I've been interested in looking at how their chromatophore system uses energy, especially because their chromatophore system, being a deep-sea octopus that lives in the dark most of the time, is much degraded compared to the ruby octopuses that we did use. So do we see a lower energy expenditure from them? And then also looking at other cephalopods, so like cuttlefish and squid, their chromatophore systems are organized slightly differently. So it'd be really interesting to see if their color change costs less or more than it does in an octopus.